Okay, Year 12s, today I'm going to be solving the 2019 Systems of Equations internal. So we've got these three graphs. We've got a parabola is number 1, and next we've got our line is equation 2, so that's our blue line, and the red lines are the hyperbola. I'm going to label that equation 3. So we want to find all the points that are intersecting on the line, so A, B, C, and D. We can find points A and C, points A and C, by solving for the intersection between the parabola and the line. So to do that, we're going to set equation 1 equal to equation 2, so the parabola equal to the line, and we're going to get x squared minus 5x minus 1 equals x minus 6. So got the parabola on the left and the line on the right. Alright, so to solve this, we need to collect all our terms on one side. So we're going to bring positive x to the other side, so that'll be a negative x on the other side, so you'll get negative 6x, and then this negative 6 will combine with the negative 1 to make a positive 5 equals 0. Alright, now you can use the quadratic formula, but this is a relatively simple quadratic, and we want to use the factors of this last number. So negative 5 times negative 1, those also are going to add to the second number, negative 6. So that allows us to quickly factorize our brackets to x minus 1 and x minus 5 equals 0, which allows us to get our x coordinates for A and C very quickly. So x1 is going to be 1 and x2 is going to be 5. From those two x values, we can get corresponding y values to build our points. So y1 is going to equal, if we subbed x1 into our line equation, we're going to get 1 minus 5, which is going to give us 1 minus 6, so negative 5. So that gives us a point A at 1 and negative 5. Alright, point C, we're going to sub in our x2 value into the line formula, so 5 minus 6 will give us negative 1. So point C will be x equals 1, x equals 5 actually, x equals 5, y equals negative 1. Alright. Right, so that's all we need to do with the parabola and the line. We can solve for the other 2 points, points B and D, by setting the line equal to the hyperbola. So we're going to go to equation 2 equals equation 3. So x minus 6 is equal to, what was the equation? 3 over x minus 4. 3 over x minus 4. So when you're rearranging this, these formulas, you want to chuck a bracket around these two, because when you cross multiply it over, you want them to be in brackets. Alright, so what we have here, we actually need to re-multiply it out and collect all our terms plus that 3 on one side. So if we expand out this quadratic, we're going to get x squared minus 6x minus 4x plus 24, and then because we're bringing this 3 to the other side, we're going to get a minus 3 on the other side, so that all equals 0. Right, so if we collect our like terms, we're going to get x squared minus 10x plus 21 equals 0. And this is actually another a basic quadratic that we don't have to use the quadratic formula for, because factors of C which add to B, well, if we had negative 3 times negative 7, we'd also have negative 3 plus negative 7 adding to negative 10. So those are going to be our numbers which we put into our quadratic, x minus 3 and x minus 7. That equals 0. So slightly different from x minus 4 and x minus 6. And that'll give us our other two solutions at x, let's just say x3 equals 3 and x4 equals 7. Alright, so those are our x values for B and D. To find the y values, we simply put our x values into the line formula. So instead of x minus 6, we've got 3 minus 6 will give us negative 3, which corresponds to point B, which has got x equals 3, y equals negative 3. And point D, we're subbing x4, which is 7, gives us a y4 of positive 1. So our D coordinate is 7, 1. Okay, and that's the end of task 1. Alright. So task 2, I'm just going to copy these, we'll call these equations 4 and 5, just so I'm calling on different equations. So I'm just going to rewrite those down here where I've got a bit of space. X minus 2 squared plus y squared equals 20. That was equation 4. And y equals negative 3x plus 16 is our equation 5. Alright, so with circles they're slightly different. You can't just set them equal to each other. You've actually got to take this line equation and substitute it in as a totally new bracket right there. So when I'm saying that I'm doing that, I always go 5 into 4, just labeling what I'm doing. So what does that look like? Just have x minus 2 squared, and then we'll have negative 3x plus 16 squared. So that instead of y squared, we now have what the line equation is equal to. is still equal to 20. Okay, now it's a simple matter of expanding and collecting our terms. So the quick way to expand all of that is you've got your first term is x squared, that's okay, and your middle term is x times -2, and then you double it, so it'll be -4x, and then the last term is going to be -2 squared, so that will be +4. So the hardest part to remember what to do is double that middle term. So that bracket expands to that. We can do the same thing with the yellow bracket. So 3x, -3x squared will be 9x squared. Our middle term, -3 times 16 is -48. Double that, it's -96x. And 16 squared is 256. And also I'm going to move this 20 to the other side, so we're going to get -20 equals 0. Alright, now we are going to collect our like terms. So we've got x squared and 9x will give us 10x squared. And we've got -4x and -96 gives us -100x. And then we've got 4 and 256 makes 260 minus 20 gives us 240 equals 0. Alright, now you've got a few options from this point. So to solve the quadratic, you can go straight to the quadratic formula with a equals 10, b equals -100, c equals 240, but I want you guys to be able to spot ways of saving time. So you should spot that all these numbers, 10, 100 and 240, can be divided by 10, so you can make the quadratic into a more basic quadratic. So if we divide by 10 on both sides, we're going to get, well, across all the terms, we're going to get -10x plus 24 equals 0. And this is actually a basic quadratic that we can solve fairly easily. So factors of 24 that add to -10, well, -6 times -4, -6 plus -4. So those are our factors. X minus 6, x minus 4 gives us our two solutions at x equals 6, well, x1 equals 6, x2 equals 4. And we can find our corresponding y values by substituting them into the line equation, which was different than our first one. So y is going to equal -3 times 6, so this is y1, plus 16. So that's -18 plus 16 gives us -2. So that's going to give us a point P of x equals 6, y equals -2. And going through our y2 point, we're going to get, so x2 is 4, so substituting x equals 4 in there, plus 16 is going to give us +4. So that completes our q coordinate of 4, 4. Alright. Part B of the test is the excellence question. So that wants you to give the equation of tangents to our circle that pass through the same y-intercept. So I'll just draw a little rough picture. Basically, we've got oops, we've got our original line going through 16, and then there's our circle. So what we're going to try and find is two new line equations that look like this. So they're tangenting on the edge. So you might remember at this condition, b squared minus 4ac equals 0. So we're going to use that to figure that out, but that comes later. So we just want to think about what do we know about these lines. We know the y-intercept. So we can fill in everything else in the line equation. So y equals m, we don't know the gradient for these two lines, that's what we're going to figure out. So mx plus 16. So we do know that these two line equations are going to go through 16, so they've got that. That's why we've got that 16 there, because they go through the same y-intercept. So we're going to rename this equation 6. Right. So I'll just put that over here with y equals mx plus 16 is equation 6. So when you're doing one of these problems, they basically start out the same as a regular intercept problem. We're trying to find where this equation intercepts our circle. So we're still going to go 6 into 4. I might just change back to blue now. So that's still how we're going to start. So we're going to get x minus 2 squared plus mx plus 16 squared. Right. So and that equals 20 still. So we've made the substitution of 6 into here instead of y. Right. So now we just want to work it through, pair up our like terms. So we'll expand these brackets. So remember from before, this one expanded to x squared minus 4x plus 4. And this following one, we're going to get mx squared will be m squared x squared. Yeah. Our middle term is going to be 2 times 16 times mx. So 32 mx. Our final term is going to be 16 squared, so 256. And at the same time, we're going to move that 20 to the other side, so we're going to get a negative 20 equals 0. Alright. Now what we want to do is collect our x squared terms together, our x terms together, and our numbers together. So when we do that, we're going to get 1x squared. I like to put a 1 in front of this x squared because then it doesn't get lost, plus m squared x squared, plus 32mx minus 4x. 256 plus 4 is 260, minus 20 gives us 240 equals 0. So what we want to do now with these, we want to pull out a factor of x squared and make a bracket. So in that bracket, for what's left over for the first term to multiply to x squared, well, might not seem like there is anything, but actually you multiply 1 by x squared to get x squared. For the next part, you've got m squared is multiplied by x squared. So if you expanded this bracket out, you'd get these two terms. The next bracket will factor out an x out of the next two terms, so 32m minus 4. I sort of tweaked it so that I'd have the minus 4 coming last. It just tends to make things easier if you get your negatives in that direction, but it doesn't matter, it'll still work out the same. Just be careful with your negatives. 240 equals 0. Okay, so what we have here, I just drew this in green, is a times x squared, b times x, and c. So this bracket here, that's our a, and this bracket here, that's our b, and that last number 240 is our c. And that's all. So that's part of our generic quadratic formula. It seems weird that we've got whole brackets as our coefficients, but I'll show you how that works in a moment. So once we're at this stage where we've gotten down to our quadratic brackets, we need to use the tangent condition. So the discriminant, which is the part under the square root in our quadratic formula, when that part is equal to 0, that is where there is a tangent solution, right? So what we're going to do is we're going to take our A, our B, and our C from above and drop them into our tangent condition. And this will actually give us a completely new quadratic, but it'll be with m's instead of x's. So that'll look like this. B squared is 32m minus 4 squared minus 4 times 1 plus m squared times 240. So just colour those in. So that's our C, this is our B squared, and this is our A from above. So now what we're going to do, this all equals 0 because that's the condition for having a tangent. Right, so what we want to do now is expand these brackets and put our like terms together. So when we expand our blue bracket here, we're going to get 1024 m squared, big numbers. Okay, we're going to get negative 250, so 32 times negative 4 times 2 will be our middle term, negative 256m, and then negative 4 squared is going to be 16. Alright, now negative 4 times 240 is negative 960. So negative 960 times 1 is negative 960, and negative 960 times m squared is going to be negative 960 m squared equals 0. Alright, so at this stage what we want to do is collect our like terms. So I'm going to put m squareds together, so negative 960 m squared, and then we've got negative 256. There's no other m's other than this 256, and then we've got negative 960 plus 16 equals 0, and that will simplify to 64 m squared minus 256 m minus 944 equals 0. Okay, so at this stage, to solve for the answers of m, you can go straight to the quadratic formula. But I generally like to simplify my numbers, and I actually halved it 4 times in a row. So actually you can divide all of these coefficients, 64, 256 and 944, by 16. So I just did that trial and error earlier. I'm not that smart, but I suspected because they were all even numbers. So 64, you're going to get 4m squared, 16m, and negative 59 equals 0. So when we're using our quadratic formula, we can use the more simple numbers of a equals 4, b equals negative 16, and c equals negative 59. Alright, so putting those numbers in to our quadratic formula, I'll just say it out loud as I write it in. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that will give us, because the plus and the minus, 2 answers for our gradient. So before I put this into my calculator, I like to do a little bit of simplification. So there's 2 negatives there, so I'll get rid of that. I'm going to evaluate everything under the bracket, and I'm going to evaluate this 2 times 4. So when I substitute into my calculator, I set it up like this: 16 plus or minus the square root of 1200 divided by 8. Alright, and that gives me 2 answers at 6.33 and negative 2.33. Not exactly, but near enough. So those gradients correspond to 2 line equations for the tangents. So tangent 1 will be y equals, so I might just write tangent equations. So y equals 6.33x plus 16. So I'm just basically I'm just replacing the m in our equation 6 with our 2 gradients. So y equals 6.33x plus 16 and negative 2.33x plus 16. Okay. Yeah. I'll just show you the Desmos I did before. So here's the situation. So we've got that circle, we've got our original line, it goes through 16, and here's our two gradient tangents. So there's x 6.33, quite a steep one, intersecting at 16, and our second tangent on the other side looks like that. Alright. So what I just wanted to reiterate is that you don't have to do this divide by 16 thing. You could take your A is equal to 64, your B is equal to negative 256, and your C is equal to negative 944. And if you put those into the quadratic formula here in the same places, work it through exactly the same, you will still spit out those same m values. Okay. Alright, so that's the end of the test, so I'll leave it there.